Now, in this section, we'll discuss about tension development in a clamped wire. Say we are having metal wire which is clamped between two rigid supports. Say these are rigid supports and the wire is just taut. Almost zero tension is considered. Say if I increase the temperature, then obviously the wire will expand and there will be a sag in the wire. So you can simply state a sag is developed if a temperature is increased, it will expand and the tension will still remain zero. But say if we decrease the tension and if it is just taut, say its temperature is decreased by delta T. In this situation, the wire will have a tendency to contract due to thermal contraction phenomena, which is just reverse of thermal expansion. In this situation, say we open the wire from one end, then what will happen? You can say the wire will contract up to this much of length, say which is delta L. Earlier it was L0, it will be contracted by length delta L, and we can write thermal contraction in length will be delta L, which can be written as alpha L delta T, alpha L0 delta T, where alpha is the coefficient of linear expansion of this wire. In this situation, if it would remain clamped at the rigid support, in that case, whichever length is contracted due to thermal contraction will be the same compensated by elastic expansion. Or if you can assume, if say it is contracted and if I hold this end and pull it and tie it up again at the rigid support, you can say that a tension is developed in it. Say the tension developed will be F and the wire is elastically expanded and again it is clamped at the rigid support. So in this situation, this tension you can call it F, which is developed within the length of this wire. So we can find out very easily the tension developed in the wire by using the Young modulus of this metal wire. As we know, Young's modulus of material can very easily be related by strain and stress developed in the material, like Young modulus can be written as stress by strain. So in this situation, stress can be written as F upon S, where S is the cross-sectional area of the wire, which is equal to S. So the stress developed in the wire due to elastic elongation is F by S, because F is the tension developed due to elastic elongation, and the strain can directly be written as delta L by L0. Or you must write instead of L0 the initial length to be L0 minus delta L, which can be taken approximately as L0. So in this situation, this tension in wire can be written as Ys delta L by L0, and delta L by L0 from here we can write as alpha delta T, so it can be written as Ys alpha delta T. So due to fall in temperature, if temperature fall is delta T, and due to fall in temperature by delta T, we can write tension in wire is equal to Ys alpha delta T. So you just keep this thing in your mind. This is also a very important result that is quite useful in various different kind of numerical problems also.